Alright, so problem 11, quadrilateral w prime, x prime, y prime, z prime is the image of quadrilateral w, x, y, z, aperture and dilation center of t. What is the scale factor? So we're going from the larger shape this time to the smaller shape. But again, so scale factor, there's two choices. We can take 66 divided by 22 or 22 divided by 66. Those are always your two choices. And we are going from a larger to a smaller, so the scale factor is less than 1. So 22 divided by 66 would simplify to 1/3. If you have chosen, let's say, these two numbers and would have done the smaller scale factor, 12 over 36, it also simplifies to 1/3. Same thing for 16 over 48. It simplifies to 1/3, as well as the last one. So if you're ever checking to see if a pair of shapes really are similar, you have to check all of the corresponding sides to make sure the scale factor is the same. You're already told that's a dilation, so that means the scale. You're being told by the word dilation that the scale factor between corresponding sides is the same. Problem 12, triangle AB prime C prime is a dilation of triangle ABC using A as its center. I would recommend anytime you have a pair of nested triangles, again, these are called nested triangles, that you separate the triangles. So the triangles are similar based on the fact that we are dilations of each other. So not only are the triangles nested, but these two segments here are also parallel because of the fact that the corresponding angles are the same. Again, here's that letter F I've been talking about. That if you have parallel lines, then the corresponding angles are congruent, and the shape that you should be able to shape there with the parallel sides and the transversal is the letter F. But by separating the triangles, you end up actually doing the scale factor with the correct numbers. So quite often what students will do is they'll use the 8 and the 6, but if you actually separate the triangles, the length of AB is actually 14. Not just 8 or 6, actually it's made up of both parts. And the same thing going the other direction for AC, which I didn't mark here, but AC is a length of 7, 4 plus 3, not just 4 or just 3. So in this problem, you have to actually come up with a scale factor, and you can do this one of the two ways that I've demonstrated. They're asking you to find the length of BX, so that means that these two numbers would be the corresponding sides. The AC, which is 7, and AC prime would be considered corresponding sides. You compare those together. AB prime is actually 8, and then AB is actually 14. So you have different options where you have both numbers. So I'm going to go ahead and I'm going to choose these two and then these two as my corresponding sides. So the proportion would be 8 goes to 14 as x goes to 21. And then we can cross multiply to solve for x. So I cross multiply at 14x is equal to 8 times 21. So 14x equals 168. And then if I divide both sides by 14 to figure out what x is, we would end up with a final answer of 12. If I wanted to do it the other way, I would take 8 divided by 14 would be my scale factor because I want it to be smaller, so the number has to be less than 1. And that would simplify to 4/7. So to go from the 21 to the x, what I have to do is take 4/7 times 21. And 21 divided by 7 is 3. So I would be taking 4 times 3, which is the 12. So a couple ways of doing it. Proportion always works. The other method, depending on the numbers, may or may not work, but the proportion method will always work. Problem 13, get some proportions. We've been doing this work since August. So we cross multiply. 7 times the quantity of x minus 2 is equal to 5 times the quantity of x plus 4. Using the distributive property, we can get rid of the parentheses. So 7x minus 14 is equal to 5x plus 20. I always take care of the x values first. I like to keep the number in front of the x to be positive. So I'm going to subtract 5x from both sides to get rid of the 5x on the right side. So I end up with 2x minus 14 equals 20. At this stage here, I always refer to like slope and intercept. I have y equals mx plus b, or the y is kind of at the 20. Got 2 steps left, that's the point. When you get in that form, you have 2 steps left, so we're going to add 14 to both sides. So 2x equals 34. And then we're going to do the multiplication problem with division. And the final answer here is x is 17. The second problem, again, cross multiplication, we're going to have 8x, or 8 times x is equal to 5 times the quantity of x plus 6. We have one parenthesis to get rid of, so we have 8x equals 5x plus 30. Subtract 5x from both sides. It's 5x minus 5x makes it 0 on the right side, so I have 3x equals 30. I have a multiplication problem to undo by dividing both sides by 3. So x is 10. Problem 14, again, you notice a general theme here throughout this review is, are you able to identify scale factor, and are you able to apply scale factor to be able to find this inside? So you're told these two shapes are similar, and there always are 2 scale factors. So you find a set of corresponding sides to create the scale factor. So if I want it to go from, if I want to dilate, it takes me from m to n. I'm going from bigger to smaller. I want the scale factor to be less than 1. If I want to go from n to m, which makes the shape bigger, then I want the scale factor to be 5/2. Always have 2 options depending on which direction you are scaling. Problem 15, again, here's another example of a pair of nested triangles. And so you may find that separating the 2 triangles it will be easier, especially if you're trying to separate proportions off from this side. So by separating them, 15 goes to the x as the 10 goes to the 4. So as a proportion, 15 goes to x is equal to 10 goes to 4. So I'm going using the bigger shape to the smaller, so the top number is the shape on the left, the bottom number is the shape on the right. Cross multiply. So we have a 10x is equal to 4 times 15. 4 times 15 is 60. Then we undo the multiplication with division. So x is equal to 6. If we wanted to do it the other way, we would, the scale factor is going from 10 to 4, so that makes it 4/10, which is also 2/5. You simplify the fraction. So to go from 15x, I would multiply the 15 by the scale factor of 2/5. Since 15 divided by 5 is 3, what I would end up multiplying is simply 3 times 2, which again is 6. So I'm trying to provide 2 ways of doing it. Hopefully you find one of them that you like over the other. Problem 16, figure A is rotated and then dilated to form figure B. What must be true? So if we're dilating the shape and if we are rotating the shape, that's basically a sequence of transformations. We're saying that the two shapes here are similar to each other because one's a dilation of the other, which means the corresponding sides will match up and have a shared scale factor, and the corresponding angles will be the same numbers. So I'll start at the bottom here. D does not work because there's if I'm doing dilation especially, there is the shapes themselves will not be the same size generally. So the key word here is dilate. So we're assuming the shapes are not the same size. The figures are similar to each other. That's a good option. They have the same size but different. They have the same size but different shapes. So that's actually in reverse. They have they're different sizes but have the same shape. So these two words here are actually switched, which is why B doesn't work. And the lengths are the same for both shapes. And we talked about this earlier, that this one doesn't work because I could have a rhombus where all the sides are 4, and I could also have a square where also all the lengths are 4, and these two shapes are not similar to each other. I can make them all 8s, so I have a scale factor 2. They're not similar to each other because there's no way to match up the angles. So the answer here is C. The shapes are similar, and when we say the word similar, we're saying that the corresponding sides have the same scale factor and the corresponding angles are the same numbers. Problem 17, select all the statements that must be true. The sum of the angles of a parallelogram is 360. This is true. Think of a rectangle. We have 4 90s. 9 times 4 is 360. Squared. 9 times 4 is 360. If I have a parallelogram, for example, the opposite sides are equal, or opposite angles are equal, but the angles that are adjacent or next to each other, they add up to 180. And so you have 2 pairs of those. That's again 360. The opposite angles of a parallelogram are congruent. That's one of our theorems. A kite is a parallelogram. This is not true because a kite does not have any parallel sides. The diagonals of a parallelogram bisect the angles. This is not true. They bisect the angles of the rhombus, for example, and the square, for example, but not all parallelograms. And opposite sides of a parallelogram are congruent. This is also true. Again, we have a theorem for that. So the answer is A, B, and E. Problem 18, describe a sequence. So one step would be do a rotation of 180 degrees. To around point X clockwise. And then I would translate the shape using vector X to L, which would put the shape here. And then my last step would be I would dilate the shape. That would be the green shape here, L, W, double prime, Y double prime, by a scale factor of 8/3. So using these two numbers here, and the shapes would be the same. Problem 9, which statements are true? Select all of them. Squares are always similar to each other. That's true. The corresponding sides always have the same scale factor. Angles always be the same. Parallelograms are always similar, not always true. Regular pentagons are always similar. Isosceles triangles are not. You can make the angles different. And kites are not. Same, you can make the angles also different as well as the sides. So they don't have the same scale factor. And the last problem, which parallelograms are not similar? Are not similar to each other? So you have to check out scale factors here. So scale factor here is 2. This is 2. And this is 2. So that one works. Scale factor here is 2, 2, and this is 3, so these are not similar.